In this session, we will analyze the BEAST output log and trees files. To analyze the BEAST results, we are going to use the program tracer. Select the Import Trace File option from the File menu and select the log file from the previous section, or drag and drop the log file into the Traces window. You will be presented with a window similar to the one shown. Remember that MCMC is a stochastic algorithm, so the actual numbers will not be exactly the same. On the left-hand side is the name of the log file loaded and the traces that it contains. Selecting a trace on the left brings up analyses for this trace on the right-hand side, depending on the tab that is selected. When selecting the age root trace, various statistics are shown under the Estimates tab. We have seen how we can diagnose our MCMC run using tracer and produce estimates of the marginal posterior distributions of the model parameters. However, BEAST also samples trees at the same time as the other parameters of the model. These are written to a separate file called the trees file. This file is a standard Nexus format file, and as such, it can easily be loaded into other software in order to examine the trees it contains. In this tutorial, we are going to use the tree annotator tool that is provided as part of the BEAST package to summarize the information contained within our sample trees. Once running, you will be presented with a window like this. First, let's use the burn-in value as the number of trees rather than the number of steps in the MCMC chain. For this example, with a chain of 500 million steps, sampling every 50,000 steps, there are 10,000 trees in the file. To obtain a 10% burn-in, set the burn-in as the number of trees value to 1,000. We will keep the posterior probability limit value to the default of 0 to summarize all nodes in the target tree. Our target tree type will be the maximum clade credibility, where tree annotator will examine every tree in the input tree file and select the tree that has the highest product of the posterior probabilities of all its nodes. Let's use the default median node heights for our summary tree. Now, in the input tree file, use the Choose File button to select an input trees file. This will be the trees file produced by BEAST. In the output file, select a name for the output tree file, for instance, yfv_rrw_cauchy_mcc.tree. Once you have selected all the options above, click the Run button. Now let's open Figtree and select the Open option from the File menu. Select the tree file you created using Tree Annotator in the previous step. The tree will be displayed in the Figtree window. On the left-hand side of the window, it is possible to find the options and settings which control how the tree is displayed. In the Layout panel, check Align Tip Labels for clarity. For appropriate scaling of time, open the Timescale tab and set the appropriate offset representing the most recent sampling date. Next, uncheck the scale bar and check the scale axis and the reverse axis within. Feel free to explore the other settings and options to arrive at your desired tree.